Now that we've simplified absolute values and we have solved absolute value equations, we're going to solve absolute value inequalities. So, by the end of this lesson, you should be able to do just that. So we can write about absolute value inequalities as compound inequalities. So we're going to combine like the and the or stuff that we did before in order to make these make sense. So when I see the absolute value of x is less than 3, this means that I want all numbers with a distance less than 3 spaces from 0. So stop and think about where all those numbers are. This is exactly 3 spaces away from 0. This is exactly 3 spaces away from 0. And if I want all the numbers with a distance less than that, then it's all the numbers this way and all the numbers this way. Where if I ask you to solve the absolute value of x is greater than 3, this means that I want all numbers with a distance greater than 3 spaces from 0. So again, stop and think about what that means. This is exactly 3 spaces from 0. This is exactly 3 spaces from 0. A distance greater than that would be everybody this way and everybody this way. So if we look at this, we can make some conclusions from this. Anytime you have a less than symbol, it's an and inequality, and it's going to be stuff in between because you want the distance to be less than something. Where if you have a greater than symbol, it's going to be or, and it's going to go out like this. So less than is and, greater than is or. LA and go. La and go, however you want to remember it. This is just simple memorization. I'm going to show you mathematically why it works out like this, but it'll be easier to just memorize. So let's solve one. I want to solve all the numbers that are in here that are less than 11. So remember, when you see this, you want whatever is inside here to be less than 11 spaces away from 0. So less than means it's going to be an and problem. Just keep that in mind. So the first thing we have to do is stop and think about what this means. This stuff in here, this stuff in here, remember, could be 11 or it could be negative. So when we do that, we technically have two cases, just like we've been doing today. We want this stuff to be positive, and we want this stuff to be negative. So we solve this one. This is nice and easy to solve. We get that we want all the m's that are less than 9. And this one here, because it could be negative, we have a negative being multiplied by all this stuff, so we're going to divide by -1. And remember, when we learned inequalities, that when you divide by a negative, you have to change the sign around. And then it becomes something easy to solve. And when we graph the solution set of this, it's easy to see where our answers fall. Oops, let's try this again. It's -13 and 9. So I want all the m's that are less than 9, which would go this way, and all the m's that are greater than -13, which means it's everybody in between. And just like I said up here, because it was less than, it's an and problem, so it goes in between. We would technically write the answer with m in between, -13 on this side, 9 on this side. You want less than 9 and greater than -13. So let's try another one. This tells me that I want all of this stuff in here to have a distance that is smaller than -3 spaces away from 0. stop and think about what that means. Can you have a distance that is smaller, let's write that out, smaller than -3 spaces from 0? And the answer is that we can't. We can't have a distance that's smaller than a negative number. 0 is the smallest distance. So for this one, the answer is no solution. So let's try a greater than 1. Remember, when I read this, the first thing that goes through my mind is the fact that that's greater than, and I know greater than problems are or problems. So that means that my solution should go out. So remember, we have two cases. The stuff inside here could be positive or it could be negative. So the first case, I take whatever's in here, I make it positive, and I just solve this. We'll subtract 6 from both sides. We'll divide both sides by 3. So we get all the n's greater than or equal to 2. Or, remember, the stuff inside of here could be negative. And when that happens, to start solving it, we want to divide everything by -1. And when I divide by -1, this is going to stay the same, but I have to change my sign and change the sign on that number. So remember, when we were doing this with equations, if I gave you this and it equaled 12, you would solve this, +12, and you would solve this, right? So same thing here, you have positive and negative, but because it's an inequality, in addition to making this negative, you have to change the sign also, and that's all we're doing here. But then solving it is exactly the same. We'll divide by 3, so we get n could be less than or equal to -6. And then when we graph this, we should be looking for it to go out. So we have -6 and +2. You could put 0 in here if you wanted. It can equal 2, and it's everything bigger. It can equal -6 and everything less. So just like before, we could write this with a big or in between. We could write it in interval notation. Oh, we need brackets here. Bracket. Bracket. Or we can leave it as a graph, and that shows our solutions. Let's try another one. I want this stuff's distance to be greater than 7 spaces away from 0. So that means that this stuff could be greater than 7. Holy cow. Or this stuff could be less than -7. So stop and make sure that makes sense in your head. So you are at 0, you have 7 and -7. Either this stuff is here, greater than 7, or it's over here, less than -7. And then this changes where our actual answers are, so our graph isn't going to look like this, but that's what this stuff means right here, that it's either bigger than +7 or less than -7. So now once we've split this up, we can solve. Subtract 1 from both sides, divide by 2, so we get all the k's bigger than 3, or divide by 2, we get all the k's less than -4. And just like we said, we want this to go out when we graph it. It cannot equal -4, that's going this way, and it cannot equal 3, that's going that way. So you could leave it like this. If I ask you, you would write it in interval notation with parentheses this time. Or you can leave it like this if I ask you. So you got 2 to try on your own. One is a greater than, one's a less than. Remember what your answer should look like. I'm sure you have some questions about this, but we'll practice this in class tomorrow. So write down any if you have them, and we can go over them. Enjoy your night.